Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are going on well. In this part 12 video from the chapter of Heron's formula, I will discuss about a very interesting property of a trapezium and area. It is that when you draw a line parallel to the parallel sides of a trapezium that intersects the non-parallel sides, then that parallel line will divide the non-parallel sides in the equal ratio, in equal proportion, and also that parallel line will divide the entire trapezium into two trapeziums whose ratio will be very much related to the ratio to which the non-parallel sides are divided by the parallel side. So that I will discuss in this video. So this video is part of the playlist CBSE Maths for class 9 following the textbook of author R.D. Sharma. If you find this video beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so we have a trapezium ABCD where the parallel sides are AB and DC, and the length of AB is X and the length of DC is Y. Now the if I draw a line parallel to the parallel sides AB and DC, that let's say I'm drawing a line, this is a line let's say this is a line which is drawn parallel to the parallel sides AB and DC, and let's say these two lines are intersecting the non-parallel sides at the point P and Q. Now the thing is that since the line PQ is parallel to the parallel sides AB and DC, then the point P, let's say the point P is dividing the non-parallel side AD in the ratio, let's say we have AP by PD. Let's say this ratio is equal to M by N. That is, AP is to PD is equals to M is to N. Now then the point Q will also divide the non-parallel side BC in the same ratio. That is, we will have BQ by QC will also be equal to M by N. So this is a property. Alternatively, conversely, if P and Q are points on the non-parallel sides such that the ratio AP is to PD is equal to BQ is to QC, then we can say that the line PQ must be parallel to the parallel sides. Anyway, so this is the one property. Now the question is, now we see that the line PQ is dividing the entire trapezium into two trapeziums, AB QP trapezium. We are having trapeziums AB QP and trapezium PQ CD. What will be the ratio of the areas of these two trapezium? That is the question. Where we only know the length of the, okay, I think to find the ratio of the area of the two trapezium AB QP and PQ CD, probably we do not need the length of the parallel sides of the original trapezium, that is X and Y. We just need the ratio M by N. Now, okay, now the concept is that the concept that will be applied is that it is based on a triangle. So if you have, so let me first explain that. So let's say we have a triangle, so any general triangle, sorry, let's say this is the triangle ABC. Now if you draw a line parallel to the BC, let's say PQ is a line parallel to BC, then the point P and Q will divide the sides AB and AC in proportion. That is, we will have AP by PB will be equal to AQ by QC. Also we will have now also the concept, this is based on the concept that the triangle APQ and the triangle ABC, the triangle APQ and the triangle ABC will be similar, not congruent but similar. That is, they will be similar triangle means they look similar but their sizes are different. So probably the ratio will be the ratio AP by, it should be I think the ratio AP by AB will be equal to AQ by AC, and also we will have PQ, this will also be equal to PQ by BC. This we will have. If so the line PQ is drawn parallel to the base BC, then that line which is intersecting the other two sides AB at the point P and AC at the point Q, then AB, the points P and Q will divide the side AB and AC proportionally. That is, we will have AP by AB is equal to AQ by AC, which is equal to PQ by BC. We will use this concept. Now, okay. Now, how do we find the ratio of the area of the two trapeziums? Let's say for the sake of easiness, I am calling the trapezium ABQP as T1, and I am calling the trapezium PQCD as T2. Okay. We have to find the ratio of area of T1 by area of T2. This we have to find, where it is given that the parallel line PQ, which is parallel to the parallel sides AB and DC, it is dividing the sides AD and BC in the ratio such that AP by PD is equal to M by N, and also BQ by QC is equal to M by N. Okay. Now, the concept is that from the vertex A, I am drawing a perpendicular on the side BC. So, let us say AS is perpendicular to the side DC, and let us say BT is perpendicular to the side DC. Obviously, since both AS and BT are perpendicular to the side DC, AS and BT will be parallel, and then ABTS will be a rectangle. It will be a rectangle. Okay. And ST will be equal to, we will have ST will be equal to AB, which is equal to X. Okay. Now, let us say the perpendicular AS intersects the line PQ at the point, let us say U, and let us say the line PQ intersects the perpendicular BT at the point V. Okay. Now, what we will have is in triangle consider the triangle ADS. Consider the triangle ADS. We have PU is parallel to DS. In triangle ADS, we have PU is parallel to DS. So this will imply that AP by AD will be equal to AU by AS will be equal to PU by DS. Now, what do we know? We know AP by PD. Okay. We know AP by PD. Okay. Okay. Now, to find the area of the trapeziums T1 and T2, to find the area of the trapezium T1, I need to know also note that AU, so this will also be perpendicular, that is AU or PV, they are the altitudes of the trapezium T1, and US and VT, they are the altitudes of the trapezium T2. So we need to find the area of a trapezium. We need the parallel sides, length of the parallel sides, and the altitude, that is the perpendicular distance between the parallel sides. Okay. So for to find the area of the trapezium T1, I need to find what is PQ. I need to find what is PQ, and I also need to find what is AU. AU. So AU will be the altitude of the trapezium T1, and PQ will be, PQ and AB are the parallel sides of the trapezium T1. Similarly, for this is for T1, and for T2 what I need is I will need PQ obviously, and I will need US. I will need US. US will be the altitude of the trapezium T2. I have to find this, and also I have to find PQ. PQ and DC. So PQ and DC are the two parallel sides of the trapezium T2. Okay. Now from here I can say that PD by AP is equal to N by M. Now if this implies, if I okay, so let's okay, so we have PD by AP is equal to N by M. It was given AP by PD is equals to M by N. Obviously the reciprocal will be equal, so PD by AP is equal to N by M. This implies if I add plus 1 to both the sides, PD plus AP plus 1 is equal to N by M plus 1. This implies PD plus AP by AP is equal to N plus M by M. Now what is PD plus AP? PD plus AP is nothing but it is AD. So AD by AP is equal to M plus N divided by M. AD by AP is equal to M plus N by M. This implies that AP by AD is equal to M by M plus N. Okay. So we have this AP by AD is equal to M by M plus N. Okay. So we can say that what will be PU? PU is equal to M by M plus N multiplied by DS. DS. Okay. And what is okay, and UV, we have ST is equal to AB. This is also equal to UV. UV is also equal to ST is equal to AB equals to S. Okay. And what is AU? AU will be, from this relation, AU will be equal to similarly M by M plus N multiplied by AS by AS. Okay. By AS. Okay. AU. Okay. Okay. Uh, Now similarly, for triangle, considering the triangle BTC, in triangle BTC, similarly we will have uh, BQ by QC, we will have BQ by BC. BQ by BC will be equal to VQ by TC. VQ by TC, this will be equal to BV by BT. BV by BT. BV by BT. Okay. And we know that BQ by BC is BQ by BC. Okay, so we know BQ by QC. BQ by QC was given as M by N. So we know that BQ by QC was given as M by N. So this implies BQ plus QC. Okay. Okay. So this implies QC by BQ is equal to N by M. This implies if I add to both sides 1, QC by BQ plus 1 is equal to N by M plus 1. This implies QC plus BQ by BQ will be equal to M plus N by M. This implies what is QC plus BQ? QC plus BQ is BC. So we have BC by BQ is equal to M plus N by M. So this implies BQ by BC is equal to M by M plus N. So we are having this constant M by M plus N everywhere. Let M by M plus N be equals to K. So it will be easy to refer to write the steps. Okay. Now, so BQ by BC, we have BQ by BC is equal to VQ by TC. So this will be equal to K, where K is M by M plus N. So then I have I do not have space. Okay. Now I have, so then what will be a VQ? What will be VQ? So VQ is K into TC. VQ is K into TC. Okay. Okay. Now what is, let's see what is, I am trying to find the length of the PQ. What is PQ? So then what is PQ? PQ is equal to PU plus UV plus VQ. PU plus UV plus VQ. VQ. What is PU? PU is over here we have PU is K into DS and AU is also K into AS. So PU is K into DS. So this is K into DS. What is UV? UV is X. UV is X. UV is equal to X. X. And what is VQ? VQ is K into TC. So if I simplify this, this is X plus K into DS plus TC. This is equal to X plus K. What is DS plus TC? ds plus tc. ds plus tc is equal to dc minus st. dc minus st. So this is dc minus st, which is equal to x plus k into what is dc? dc is y. One of the longer parallel sides of the original trapezium is dc. It is y. And what is st? st is x, that is the shorter parallel length of the shorter parallel side AB, x. So you see, we get PQ as, that is the length of PQ is equal to x plus k into y minus x, which is basically x we know, k we know is m by m plus n multiplied by y minus x. So this relation we got from the length of the PQ we got in terms of xy and the ratio, given ratio of AP and PD. Now, okay. So then, what will be the area of trapezium T1? Area also we okay. Now, also see that we will have AU by US. What will be AU by US? AP by PD is equal to AU by ES. AU by AS. AP by AD is equal to AU by AS. Okay. Okay. So we know AU is equal to K into AS. AU is equal to K into AS. K into AS. Okay. Also, okay. So what is the area of the trapezium? Then T1. It is half multiplied by the sum of the parallel sides, that is AB plus PQ. AB plus PQ multiplied by the altitude of the trapezium is AU. Altitude of the trapezium T1 is AU. AU. This is equal to AB plus PQ. Okay. What is PQ? PQ. Okay. Okay, so this is equal to half multiplied by AB is x. AB we know is x. AB is x plus PQ we have found to be PQ we have found to be x plus k. I'm using k, which is equal to m by m plus n. So x plus AB is x, so PQ is x plus k into y minus x multiplied by AU. What is AU? AU is k into AS. AU is k into AS and AS, okay, k into AS. Let it be k into AS. So this is equal to half multiplied by 2x plus k into y minus x multiplied by k into AS. Okay. Now let's try to find what will be the area of the trapezium T2. Now it is a lot of computation, but please do not be afraid of this computation. The result will be very interesting. Let's see. So area of the trapezium T2 is half into one of its parallel sides is PQ and the other parallel sides is DC multiplied by the altitude of the trapezium T2 is US. So it is US. This is equal to half. PQ was x into k into y minus x, and we have plus DC. PQ is x into k into y minus x, and we have plus DC. What is DC? DC is y. DC is y. This is y. DC is y. Okay. And we have multiplied by US. What is US? We have got US equal to US. Okay. We know AU. So AU is equal to K into AS. AU is equal to K into AS. So what is US? US is AS minus AU. What is US? US is equal to AS minus AU. This is equal to AS minus AU was K into AS. AU was K into AS. So this is equal to 1 minus K multiplied by AS. Okay. So this is 1 minus K multiplied by AS. Okay. Now, if you take the ratio of the area of the trapezium T1 and T2, clearly AS will cancel out, half will cancel out. Okay, so what is 1 minus K? What is 1 minus K? 1 minus K is equal to K we have assumed to be M by M plus N. So this is, if I simplify this, it will be N by M plus N. Okay. So then, so then area of T1 so then the area of T1 divided by area of T2 will be equal to half will cancel out, AS will cancel out, and we will have K into 2x plus K into y minus x divided by, we will have 1 minus K multiplied by x plus y plus K into y minus x. Now we know K is actually M by M plus N. Okay. Now this ratio should be independent of x and y. The ratio of the trapezium T1 and T2 should be in terms of M and N, because it all depends where how in what ratio the parallel line PQ is dividing the non-parallel sides AD and BC. In that same ratio, the ratio of the trapeziums T1 and T2 will be the same as the ratio in which the line PQ is dividing the non-parallel sides AD and BC. So this ratio must be independent of x and y. How can it be independent of x and y? We are having x and y. Okay, let me see what is actually 2x plus k into y minus x. So this is 2x. If I put the value of k as m by m plus n, we have this multiplied by y minus x. Okay, if I simplify this, this is this will be this 2x. Let me check once again if I did this thing correctly or not. What is PQ? X k into ds plus x plus k into tc. ds and tc, y minus x. dc minus st minus x. PQ is equal to x plus, okay, area of trapezium. Okay, let's see what happens. So this is, if I simplify, this is 2xm plus 2xn plus my minus mx by m plus n. This is equal to this will be equal to mx plus my plus 2xn. Okay, divided by m plus n. Okay, and what is x plus y plus k into y minus x? Area of points. Area of trapezium T2 is half into PQ plus DC. Some of the parallel sides are PQ, okay, plus DC. Okay, so let's see what is this. So this is x plus y plus k is m by, what was k? K was m by m plus n. M by m plus n multiplied by y minus x. This is this is, if I simplify, xm plus xn plus ym plus yn plus my minus mx by m plus n. mx cancels out, so this is equal to n into x plus y plus twice my divided by m plus n. And this was equal to m into x plus y plus 2xn divided by m plus n. Points 1 1 2x. No, I think the area of in the ratio of area of T1 and T2, I might have done something wrong. We will not, this ratio is not coming independent of x and y. In this ratio, there should not be any x and y. It should be purely based on k, or where k is basically m by n plus n. Let me quickly check once again if I did the calculation of the length of PQ and the altitude AU and US correctly or not. So we have considered AP by PD to be equal to m by n. Okay, so this implies PD by AP will be equal to n by m. Okay, and then if I add over here, if I add PD by AP, if I add 1 to both sides, I have PD by AP plus 1 equals to n by m plus 1. This implies PD plus AP by AP equals to n plus m by m. Now PD plus AP is equal to AD. So AD by AP is equal to m plus n by m. Okay, AD by AP. Okay. So this implies AP by AD is equal to m by m plus n. This is fine. AP by AD is equal to m by m plus n. So we will also have then, so we have then we also have, we know that from the triangle ADS, since PU is parallel to DS, then we will have AP by AD is equal to AU by AS. It will be also be equal to PU by DS, which is equal to m by m plus n. Okay, then PU will be equal to K into DS. Okay, PU will be equal to K into DS. Okay, K into DS. So similarly, we will have VQ. VQ will also be equal to K into TC. So VQ is equal to VQ is equal to where is VQ? Okay, VQ is equal to K into TC. Okay, so then PQ is equal to PU plus UV plus VQ. PU plus UV plus VQ. PU is equal to K into DS. So K into DS plus UV is equal to X. UV is equal to X and plus K into TC. K into TC. Okay, so we have X plus K into DS plus TC. DS plus TC. Now DS plus TC is equal to DC minus ST, that is Y minus X. Y minus X. So PQ is equal to X plus K into Y minus X. This is fine. This is fine. Okay. Half. So Y by 2. X plus Y by 2. I think I am I have stated the problem probably incorrectly. I think we have to find the ratio of the trapezium ABQP, which is T1, and the original trapezium, that is ABCD, that is ABCD. Yes, I think I am. I am trying to find some. We cannot. I think it is not possible to find the ratio. I mean, the ratio of the trapezium T1 into T1 and T2. It will have. It will not be independent of x and y, but the ratio of the trapezium T1 and the whole trapezium, that is ABCD, that ratio will be purely based on m and n. So let's see. Okay. So what is the area of the trapezium T1? Area of the trapezium T1 is it is uh, uh, 2x. Okay. So area of the trapezium T1 is this thing. Okay. And what is the area of the original trapezium? That is the whole trapezium ABCD. So area of the trapezium ABCD, we know, will be equal to half multiplied by the sum of the parallel sides, which is x plus y, multiplied by the altitude will be original trapezium, altitude is AS. Okay, AS. So then the ratio of the trapezium T1 and the area of the whole trapezium ABCD is area of trapezium T1 was this. So AS and half will cancel out. So we will have K into we will have K into 2x plus K into y minus x divided by x plus y, because as and half will cancel out. Area of trapezium T1 is this. So as and half will cancel out. So the ratio will be k into 2x plus k into y minus x divided by x plus y. Now is x plus y. Okay. Now the interesting thing is that if it is still not coming independent of x and y. This ratio is not coming independent of x and y. X plus y is this thing x plus y by 2, x plus y by 2. X plus y by 2 half x plus y by 2 x plus y. Mm, plus y. Clearly, the longitude of the trapezium T1 is and the ratio is the ratio of the altitude of the trapezium T1 and the original trapezium, that is AS. It is equal to that ratio is in terms of m and n, but the sum of the parallel sides of the trapezium T1 is AB plus PQ, and the sum of the parallel sides of the original trapezium is AB plus DC. AB plus DC. So AB plus PQ. So AB plus PQ. The ratio of the sum of the parallel sides of the trapezium T1, that is AB plus PQ divided by AB plus DC, this ratio must be a constant, that is it should be in terms of m and n. Then we can then the ratio of the trapezium T1 and the ratio and the area of the trapezium ABCD will be in terms of m and n. Now, will this ratio be independent of x and y? DC PQ is equal to half of DC y. PQ so it's midpoint. PQ we got PQ as PQ was PQ is x plus k into y minus x. And AB is x. Sorry friend, I think I messed it up. I thought that the area of the trapezium T1 ratio of the area of trapezium T1 and the ratio of the original trapezium will be in terms of the ratio by which the line PQ is dividing the non-parallel sides, but it seems the ratio of the area of the trapezium T1 and the area of the trapezium ABCD is coming in terms of x and y. I'm sorry friends, this is a very weird situation. The objective of this video is not met, but still please give it a thought. Maybe I am wrong somewhere. If you think that I did some calculation mistake, if you think that it is possible that the ratio of the trapezium ABQP and the trapezium ABCD will be in terms of m and n, where we are having where the what is m and n? AP by PD, that is the parallel line PQ is dividing the non-parallel sides in the ratio m is to n, that is AP by PD is equal to m is to n, and also BQ by QC is equal to m into n. If you think the ratio of the trapezium ABQP and the trapezium ABCD will be in terms of m and n, if it's possible, then please do let me know. I will highly appreciate that. But this is an important concept based on which there are various problems you will see in the textbook of author R.D. Sharma. Anyway, so I don't know whether this video will be useful or not. If it is so, then please like it, share it with your friends, and let me know what you think about this ratio of the trapezium ABQP and the trapezium ABCD, whether it will come in terms of M and N or not. I will highly appreciate that. I am ending the video here. Thanks for watching, and until the next video, take care and bye.